Welcome to this week's ML Safety Report, where we talk a bit about robustness in machine learning and the human-AI dichotomy. Stay tuned until the end to check out several amazing competitions you can participate already today. First, robustness is a crucial aspect of ensuring the safety of machine learning systems. A robust model is better able to adapt to new datasets and is less likely to be confused by unusual inputs. By ensuring robustness, we can prevent certain misalignments caused by malfunction. To test the robustness of models, we use adversarial attacks. These are inputs specially made to confuse the model and can help us create new defense methods against these. There are many libraries for adversarial example generation in computer vision, but a new attack method, TextGrad, creates adversarial examples automatically for text as well, with state-of-the-art performance. It works under the two constraints of text being much more discrete than images and therefore harder to modify without being obvious, and still ensuring that it's a fluent and readable text, i.e. making the attacks hard to see for a human. And you can see many more text attacks in the aptly named text attack library, which is one of these adversarial generation libraries. And in the paper, Certified Adversarial Robustness for Free, and yes, that is indeed its name, they find a new method for making image models more robust against different attacks, without training their own model during defense, but using off-the-shelf models, something other papers have not achieved without a severe hit to their performance. And they even do this and get the highest average certified defense rate against the competitive models. Additionally, Li and Xie investigate how to defend against the simple attack of writing a weird sentence in front of the prompt that can significantly confuse models in question answering settings. They then extend this to the image text domain as well and modify an image prompt to confuse during question answering. This is a good example of this sort of multimodal robustness that we are also looking for in future ADI. And with these specific cases, is there another way for us to generally test for examples that might confuse our models? This is generally called out-of-distribution detection, and the new OpenOOD, so Open Out of Distribution library, implements 33 different methods from the last 4 or 5 years, and represents a really strong toolkit to detect malicious or confusing examples. And their paper details much more of their approach. Another way we generally hope to detect these anomalies is by using interpretability methods to understand what happens inside the network and see when it breaks. Bilodeau et al. Criticized traditional interpretability methods such as SHAP and integrated gradients by showing that without significantly reducing model complexity, these methods do not actually outperform random guessing, which is quite crazy. And much of ML safety work, our work for example, and our hackathons, work with mechanistic interpretability that attempts to reverse engineer neural networks, something that seems significantly better and more functional for understanding what is happening within the networks and detecting these anomalies. In December, Dan Hendricks, the lead of the Center for AI Safety at UC Berkeley, published an article discussing the potential for artificial intelligence systems to have some natural incentives that work against the interests of humans. He argues that in order to prevent this from happening, we must carefully design AI agents' intrinsic motivations, impose constraints on their actions, and establish institutions that promote cooperation over this evolutionary competition. These efforts will be crucial in ensuring that AI is a positive development for society, since competitive incentives from evolution means that AIs will, prefer their own species in a way over humans. This Center for AI Safety at Berkeley is just one example of academic research in the field of machine learning safety. They also regularly and just recently published a newsletter on ML safety, which is highly recommended for readers who are interested in hearing more about these topics. It goes a bit more in depth in specific papers and within these different topics of machine learning safety, for example, robustness. Another notable researcher in this field is David Kruger at the University of Cambridge, who recently gave a comprehensive interview on the Inside View, an AI safety podcast, which is also highly recommended for those interested in the alignment of AI and the role of academia in addressing the challenges of AI safety. In other research news, we just finished a small AI Trends hackathon with the Epoch AI team in Mexico City, and the resources and ideas for the hackathon are still up for grabs, So you can create an interesting project in understanding how future AI might look using these resources. And you can check out those in the description below. And Søren Mein, Richard Ngo, and Lawrence Chan released a major rewrite to their paper, The Alignment Problem from a Deep Learning Perspective, focusing more on these concepts of deceptive reward hacking, internal goal seeking, and power seeking. Jorskalte also released a perspective article on why he thinks large language models are not general intelligence, something that is, a very interesting discussion point these days. And now to some of the great opportunities in machine learning safety. The SafeBench competition is still underway, and a lot of interesting ideas have been released for you to get inspiration from. With a prize of $500,000, you probably have quite a large chance to win an award by submitting some of your ideas. And I don't even think that the submission is that large or needs to be that large. So go ahead and try it out. 2 other prizes have also been set up for alignment. The Goal Misgeneralization Prize for accepting ideas on how to prevent bad generalization beyond the training set. Basically some of the same problems we're looking at when we look at auto-distribution and robustness. And the second prize is the Shutdown Prize. This is about this concept of corrigibility, which is about making sure that AIs actually want to be updated by humans and don't prefer to keep their own value set, for example, instead of updating through some new instructions that they receive. And in this case, it's also a question of, can it actually be shut down, even when they're highly capable? So these are both from the Alignment Awards team and have prizes for good submissions of up to $20,000, with even some, if it's very exceptional, might reach $100,000. So this easily warrants setting off a few days to work on these problems, and we of course recommend you do that. The Stanford Existential Risk Conference is also looking for volunteers to help out with their conference in late April. The Century Fellowship from Open Philanthropy is still open for applications and allows you to work on important problems during 2 fully paid years from their side. And our Mechanistic Interpretability Hackathon is happening next week, the Friday the 20th, and it's open for everyone internationally, digitally, and will simultaneously happen in over 10 locations internationally. So we have jam site locations in Copenhagen, in Stockholm, in Oxford, in Stanford, in London, in Paris, in Tel Aviv, in Berkeley, in Edinburgh, and Pittsburgh. And you can check out the website for an updated list. We might also get some in Australia, for example. So join those locally or just join us online. So thank you very much for following along in this week's ML Safety Report, and we will see you next week. Remember to jump down in the description to check out some of the links that I've mentioned here. Thank you very much for watching.